future of humanity lies within the stars, and if we ever wanted that badly enough, according to an article by Singularity Hub, optimistically thinking, interstellar travel could be achievable within a lifetime. Now to start, what would need to be done in order for that to happen? Let's come up with a scenario that humanity as we know it would come to an end from a planet-busting asteroid. We only have one chance, one design to create the perfect starship to get us to the nearest star system, Alpha Centauri. Alpha Centauri would probably be the best bet as it's the closest system to us, only being 4.4 light years away. And in order for that to happen, we would need massive amounts of political cooperation, money, and just single-minded focusedness. The key being finding the right balance of speed from our starship to reach our destination within the span of a human life, and enough time to craft and develop our ship. Option 1, traditional rocket fuel. To give you an idea, the fastest probe rocket ever was aboard the Helios, which reached speeds of up to 250,000 miles per hour, which would take up to 18,000 years to reach the next star system. So, according to an article by Mark Frigg, propellant is the biggest problem when dealing with this sort of stuff. The rocket equation, max speed, which is based on exhaust velocity, fuel mass, and spacecraft mass. So, if we want to get to Alpha Centauri within a human life, we would need to be traveling at least 10% the speed of light. So, rocket fuel is out. Another way to achieve high velocity without the use of rocket fuel is instead of propelling a lot of mass backwards, what if we propel less mass at a much higher velocity? Only needing fuel with the highest energy density, where less mass directly converts into energy. Option 2, fusion. Alright, so obtaining a constant flow of fusion energy is pretty hard to do realistically. So instead of that, why not just get mini nukes and detonate them behind our ship one by one? Now, this was a real experiment thought up for the Orion project. In an analysis project by David Snozzy titled To the Stars by Atomic Bomb, assuming that we are using modern thermonuclear devices, we would need to, over a course of time, detonate 3/4 of our starship's mass in hydrogen bombs and blast them off one by one, and gradually reach up to 10% the speed of light, reaching Alpha Centauri in around 44 years. But we forgot to take into account slowing down on the other end. So to combat that, we would probably need to use half of our fuel just to slow down at the other end, bringing our arrival time of up to 90 years. So, paired with a massive enough starship and hope that space babies work, fusion might be our answer for interstellar travel. But what if we could go faster? Fusion only converts less than 1% of rest mass into energy. What if we could get up to 100% conversion? That's the thought behind option 3, antimatter drives. When matter is met with this counter-antimatter part, they both annihilate and liberate most of its rest mass into energy. This is extremely efficient. According to Kevin Bosner in his article, How Has an Antimatter Spacecraft Will Work, creating and storing antimatter is a big obstacle, with our only source of antimatter coming from particle accelerators. It's hard and immensely expensive, only being able to produce only a few atoms at a time, and not the kilograms we need. Pretending we figured that problem out, pion rockets is our answer. With the pairing of proton and antiprotons, we can create charged pions that move at light speeds, creating the thrust we need, at more than 50 times more energy per kilogram than fusion, accelerating us up to 50% the speed of light, arriving in 9 years. Now, all this talk of propellant doesn't really help much for our problems, as it either is too efficient or too expensive to use. So what if we didn't need a propellant at all? What if we sail across the stars on the wind of light? Option 4, light sails. I'm talking about a sail coated in sapphire riding the beam of a gigantic laser, blasting away with the power of 100 nuclear plants. Now, most of that thinking has been done in favor of unmanned probes, but if we are talking humans, we're going to need a bigger boat. In Setting Sail for the Stars by Dr. Mamta Patel, to start, he explains our laser needs to be ridiculously large and visible, probably built on the moon with helium-3 reactors. Now, how fast does this thing go? Since because we aren't using any fuel, our max speed is only limited by the power and combination of our laser, and the size of the sail. The longer the effective beam is, the higher the speed we could reach. But again, slowing down is a huge factor when dealing with this sort of stuff, so this sort of tech is probably reserved for the future. Finally, option 5, saving the fun for last, black hole drives. Specifically, a Schwarzschild Kugelblitz. In a PDF study by Lewis Crane, Are Black Hole Starships Possible?, he believes that through an artificial powered black hole, it could be the fastest option for intergalactic travel. What's artificial about it, you may ask? Well, this black hole is actually powered by light. So, if we could get lasers sufficient enough, focused into a really, really small enough region, it could theoretically bend space-time just enough to produce a singularity, called Kugelblitz. A black hole, if you didn't know, constantly goes through Hawking radiation, slowly evaporating away. And a black hole of the right size could radiate like crazy, giving off tons of energy. The sweet spot is a black hole that weighs in around 600 billion kilograms. That would roughly be the size of a proton. Such a black hole would radiate up to 160 petawatts in the span of 3 to 4 years, which, put into better terms, 160 petawatts would be roughly around 10,000 times the world's power consumption. Harvest the radiation it produces, and it could easily accelerate us up to 10% the speed of light in less than a month, and later a great fraction of that speed. Besides the obvious, the only drawback is that the lasers creating the black hole must be more powerful than the black hole itself. A possible but very, very, very distant tech. Now, with everything that I've said so far, what's the fastest option to colonize Alpha Centauri if we start right now? Nukes, like the Orion project. We do have the technology required for this option, only needing to increase the world's power supply by a lot, or nuclear supply by a lot. If we had the time, antimatter and black hole drives are the starships of the far future, with near-term realities being a light sail, as it would be a great opportunity to land probes on distant star systems and to find a new place we could call home. Thank you.
Good job, man. All right.